In today's video, we will do all the problems they can possibly ask you on the exam about index of hydrogen deficiency or degrees of unsaturation. The problem-solving skill here is if they give you a condensed or an empirical formula, you would use this formula to figure out the IHD. And if they give you a molecular drawing, you would figure out the IHD by counting the number of rings plus the number of pi bonds. And remember, triple bonds have 2 pi bonds, double bonds have 1 pi bond. Now let's try the first problem. How many double bonds or rings are there in C10H16? We will figure out the IHD using the formula. 2 times number of carbons plus 2, that's 22, minus the number of hydrogens. So spoiler alert, it's going to be an IHD of 3. So an IHD is made up of a number of rings and pi bonds. That means in this 3 IHD, there could be 3 pi bonds, there could be 2 pi bonds and 1 ring, and etc. So this formula is really easy to memorize. It's like 2 carbon and then plus a 2 because there was a 2 in front, 2 carbons plus 2, and then minus the hydrogens. And if you have extra things in your formula, you would plus a nitrogen and minus all the halogens. Divide by 2. Another problem they could ask you is how many moles of hydrogen will react with this molecule? This molecule has an IHD of 2, there's a double bond, and there is a ring. So you might think, well, IHD of 2, that means there's 2 moles of hydrogen that can react with this, but no. Because the moles of hydrogen can only react with the number of pi bonds that there are, okay? With the number of pi bonds. That means even if your IHD is 2, there won't be 2 moles of hydrogen reacting with it, because remember, when you're adding hydrogenation, it's going to turn the unsaturated alkyne or alkene into the saturated alkane. But in this case, there's only 1 alkene. So there's only going to be 1 mole of hydrogen that will react with this molecule. It cannot react with the IHD based on a ring because there's no way it can break the ring just by adding hydrogens. Likewise, in this problem, how many moles of hydrogen will react with this to do hydrogenation? So here we have 2 pi bonds, and here it's an alkyne which also has 2 pi bonds, because an alkyne is made up of 2 pi, 1 sigma, and an alkene is made up of 1 pi. So the IHD is 4, and there can be 4 moles of hydrogen that react with this molecule because none of these are rings. Now, some very important notes is that a benzene has an IHD of 4. Super important. And in this sample problem, it's easy to just count the double bonds. But remember to count the ring. So there is an IHD of 3 here. Here, there is actually a secret double bond because it's an ester. So this is the R group, this is the other R group. So this accounts for 1 IHD. And when they say vinyl, you might think, hey, it's not an alkene, it's not an alkyne. But if you draw it out, you will quickly remember that vinyl does have a double bond. So both of these also have an IHD of 1. The biggest thing is being able to recognize their condensed formula or their common names and then know that, oh yeah, it's actually a pi bond somewhere in there. If you see a CN in whatever molecule, there's an IHD of 2 because CN actually has a triple bond and CN is just a condensed way of writing it. The last example problem is if you react this molecule with hydrogen and a catalyst, what will you get? So the tricky thing about this is you might think, okay, well, I'm adding hydrogen to it, so the alkene is going to become an alkane, so I'm just going to say the same thing except change it end to hexane. Incorrect. Okay, so draw it out. If this alkene disappears, what will happen is you're going to have this molecule, and instead of counting this way to give the alkene the second priority, now in the new molecule you're going to count this way, which means instead of 5 chlorocyclohex some things, it's now going to be 3 chloro. So the biggest thing here is that if they ask you, will this hydrogenation reaction happen? And you see this entire lesson, we've tied in hydrogenation and IHD. Will hydrogenation happen? Will adding hydrogen create a new product? It's important to note that it has to be an unsaturated alkene or alkyne at the start, and then you add hydrogen to make it saturated alkane. But if the molecule they give you here, let's say they gave you this to start with and ask if you do this reaction, will it happen? No, because if you already start with a saturated molecule, there will be no reaction to give you another saturated molecule by adding more hydrogens and a catalyst. So I hope this video was helpful. If it is, make sure to drop a like and maybe subscribe.